It is a very balmy day out there, a very warm temperature. I think it went as high as 10 degrees, positive 10. So that meant that we jumped, I'm being very nerdy and numerical here, jumped about 15 degrees Fahrenheit since the morning time. So, well, welcome to the very first presidential lecture series feature of the new semester. And welcome to the spring semester of 2025. Boiler up to all of you. And tonight we have a very special guest lecturer and a very special treat for me and all of us here. As an outstanding business leader in American semiconductor industry and a global pioneer in the chips industry, Dr. Tom Caulfield became the CEO of GlobalFoundries, a multinational leader in semiconductors in 2018. And then he took it from a private company to a publicly listed company on Nasdaq in October 2021, one of the most prominent, largest IPOs of that industry over those years. And Tom and I have met many times over the years. And one of the very first phone calls I made 2-3 years ago when Purdue, under the great leadership from faculty including Mark Lundstrom, Vijay Raghunathan here, started the semiconductor degrees program, was to Tom. And he endorsed Purdue's program wholeheartedly, directed his technology leadership team to work with us. Some of you might be students tonight here participating in that SDP program. And over the past several years, GlobalFoundries has been one of the strongest partners in education and research innovation programs here at Purdue. So wonderful evening here and a great delight to welcome to the Boiler Nation the CEO of GlobalFoundries, Dr. Tom Caulfield.
Thanks for those kind words.
Thank you, Tom. Well, welcome to Purdue here. This is almost like upstate New York snow level, or like 50% of the snow you're used to.
Yeah, it's a little warmer.
A little warmer, yes. Well, maybe you brought the temperature to this West Lafayette, Indiana land here. Well, we've got tonight audience who are students, faculty, staff, neighbors, and we're very proud of having this presidential lecture series started by my predecessor, Mitch Daniels, to bring to Purdue the most outstanding thought leader and society leaders. So delighted to have you here tonight. And want to start out not about your industry or your company, but about yourself, Tom, if I may. Because a lot of people think, wow, the CEO took company IPO and doctor, maybe was born to be like this. But I happen to know that like many of our students here at Purdue, you were not born into a trajectory like this. And your grit and educational opportunities open many doors you may not have thought about when you were a kid. So please tell us a bit more about where were you when you were like 10 years old-ish, and when did it happen to you that, hey, maybe one day you'll get a PhD from Columbia, one day you'll be the CEO of a major company? Please.
I think we had those ambitions. My father was a New York City firefighter, so we grew up in the greater New York area. I was a kid with my friends now that my father worked hard to move out of Brooklyn. Now you have to work hard to afford to live in Brooklyn. And so for my family, who my mother was kind of first generation, her parents were immigrants, and my father was around for a couple of generations. They never had the opportunity for education, so education was going to be a big thing for them. And for my family, they gave me a lot of latitude to do what I wanted to do, but it always came with, you have to deliver the goods academically and live up to your potential. And so I think you hit it right in the head. As a young kid, you know you're going to go to college. You're the first to go to college in your family. Your ambition is, I want to become an engineer and be able to take care of myself. And where do a lot of first-gen college go? You go to engineering because it's a more of a guaranteed job, and typically you start out making more money. And that was the selection. You had aptitude for science and technology. You became an engineer. And little did I know, I wasn't going to go get a PhD. The only requirement my father put on me, and I think this is something for all of us, is don't confuse the difference between an education and a vocation, and make sure you get both. And if you're going to be an undergraduate and stop there, and make sure you do enough on the liberal arts as you do in the technology and engineering. I did a 3-2 engineering program, 3 years at liberal arts school, 2 years in engineering. And I didn't know any better. I just went on because a professor said, you want to get a doctorate? I said, why not? It's free. How much? He says, no, we pay for you to go. I said, well, I'm going to go do that. And so a lot of my career was just following my instinct and exploring and being willing to kind of destabilize myself and be willing to do things I didn't ever think I was going to do before. And then you wake up one day, you're 59 years old, and someone asks you to go lead a semiconductor technology company. And there's a lot in between there, but that's kind of the story.
Yes. Well, we have a lot of first-generation students as well. And as you said, first in their families to go to a 4-year college. And we're very proud at Purdue with excellence at scale with affordability. And I want to come back to the affordability question in a minute. But very proud of the fact that Purdue, as a public land-grant institution, we're always rooted in the spirit that public education is the public good. We'd like to open the door as wide as possible with the highest quality to uplift people's lives and provide that socioeconomic mobility wherever you were born into, that you have the opportunity to become who you would like to become. So your story as a first-gen student in your own life is certainly inspiring to all of us. Now, about your industry, I always say that semiconductor, it is the foundation of the entire digital economy, and it's the foundation for national security, economic security, job security.
Supply chain security?
Supply chain security, things ranging from the car dealers, they've got cars that they cannot put on the lot because they're missing a few chips. We saw people getting furloughed, for example, 3 or 4 years ago in our own state here, in our neighborhood here because of that. And that's just one example of the importance of this industry. And I'm proud to say this is preaching to the choir, doing commercial within the family, but nonetheless, I'm paid to do that, so I'll do that. It is a fact that Purdue is America's #1 university in the semiconductor direction, and people ask, whose ranking is that? I said, that's my ranking. Happens to be the correct ranking as well, in education, in research, and in industry partnership. Now, industry partnership, as you know, last year, SK Hynix, the global leader of high bandwidth memory for AI memory chips supplier in the world, including to NVIDIA, after 2 years of selecting different sites options, decided to come to Purdue Research Park here in Indiana to start out with a $4 billion investment and grow that further. So we're excited to see a cornerstone of the AI industry to be rooted here in West Lafayette. But at the same time, we have heard you can also use AI and robotics to help you make chips. So it's like a full circle. The chips enable the AI, but AI can enable the manufacturing revitalization in the future version of Industry 4.0 for manufacturing of chips. So what is your view and your company's view on the interactions between AI and semiconductors?
Yeah, I think there's one more part of that loop. There's a design element of it. And so AI can help us manufacture chips. AI can help us design chips.
Yes.
The way I think about the impact is from a manufacturing perspective, it's still a physical analog activity. And so there's only a certain amount of work that can be done by AI. It can be made more productive. You maybe need less human intervention, but there's a certain amount that's purely human analog. Maintenance on tools, the running of the factory. But when you think about things that are done in the digital world, like design, they're the ones that are most ripe for the most disruption. And how I think about how AI will change our industry, it goes something like this. The reason the industry went from vertically integrated companies, if I make a product, I manufacture the product, to a design level of customers, of players. You think of NVIDIA, AMD, Broadcom, Qualcomm. They're all what's called fabless semiconductor companies. They don't manufacture anything, they design, and then they use foundries like GlobalFoundries, TSMC, UMC, you can name the handful of semiconductor foundries of any scale that do that. But the reason that happened is because scale counts. And people needed to aggregate their demands for someone at scale to build it. There wasn't enough volume for everybody to have their own fab and their own capability. So when the design community was born, a lot of that was because of two reasons. One, they can be a designer without a factory now. They could go to a foundry. But mostly it was because design started to cost more and more. And a company who made an end product, a system, couldn't afford to design their own chip because that cost to do that was too high. And so what they would do is they would take components, standard products off the shelf, a microcontroller, an I/O bus, put that together to create a product because the barrier to do the cost and barrier to do their own design was prohibitive. Now, so they had their moat based on economies of scale. I make a microcontroller, I make it for hundreds of companies. When AI comes along, it takes that cost to do design and knocks it down by an order of magnitude, 2 orders of magnitude. Why would I, as a system company now, maybe I can afford to do my own designs. I have enough volume, and I can actually integrate 3 chips into one and do a lot of customization. So my view of the industry change for AI is going to be, we're going to see more and more synthesized design, more customization, orders and orders of magnitude of more part numbers and SKUs of silicon that are very custom, workload dependent, because the economics of creating a design and bringing it to manufacturing are going to be really lowered. Now, so that's on that side. The other side is we will use AI like everybody else to become more efficient and more productive in how we make decisions, taking advantage of the thousands of terabytes of data we generate every day and how to use that data to run factories better.
Right. One of my PhD advisors, Tom Cover, who passed away now, but he did a lot of pioneering work in machine learning. And back then, I remember he was telling me that, all right, we tried to do AI in the 50s and 60s, sort of a dead field, and don't touch it again. But, it came back in part, I guess, because of the availability of data, and in part because of the availability of the computing power. And then many other wonderful things happened once triggered. Now, you highlighted the interesting observation that what AI can do for the design part is not only quantitatively making it faster, better, more efficient, but qualitatively changing the roles of the companies in supply chain. Right? So Apple started thinking that, hey, you know what? I'm going to design my own customized chips. That's a big news. And then Amazon said similar things.
Yeah.
And then others started thinking. So it's almost like every reasonably large tech companies, whether it's a car company, it's an aeroplane company, any other companies, pharmaceutical company, maybe one day soon they all say, you know what? I can design my own chips now. And that's an earthquake to the industry.
Exactly. And here's the reason why. Apple can do it because they sell 240 million of those devices a year. They have the volume. What you're going to see is companies with smaller volumes. Mm-hmm. It becomes affordable to do their own design. And what does Apple do? They design that processor for the workloads, for very specific to the workloads. Mm-hmm. Think of every system company, every electronic device can customize their logic and their semiconductor to their workload.
Now, Purdue would like to, along with many partners, become that new global headquarters where every company can become its own chip design company. But that's another commercial. I only do 8 commercials today. Now, but coming back to this bifurcation that happened several decades ago, used to be you design the chip, you make your chip. Right. And like many industries, starts to have vertically separated steps so that you specialize in one of the two. And we'll later come back to your company's history as part of that bifurcation. But what do you think about this notion that it might still be possible to have one company that can do design and manufacturing at the same time? Is that still viable?
It's going to come down to, depends. Why did the industry disaggregate? It's always, the heart of semiconductors is the intersection of technology and economics. Right? Moore's Law was an economic model. It was, why do we invest every year to create the next feature size? Is because you're going to get a transistor that has half the cost, twice the performance, and half the power used. Once Moore's law ran out of steam, the economics is gone. A transistor today costs more than on single-digit nanometer technology than on anything that's a planar device, so FinFET type of 3D structures. The performance is very marginal generation to generation. You can lean in and call it 15%. The power per transistor is still doing pretty good. That's why you see people making huge investments to go from 5 to 4 to 2 nanometer. It's for these data center applications, by and large, that require finding ways to minimize the power per transistor. So what happened in our industry, scale and complexity became so high that the cost to build a factory was unaffordable for a product company. Apple's doing its own chip now because it has enough volume. What will require the reintegration of this industry, or what would change the model, is back to, if one of those areas of complexity reduces, then you can see reintegrating back where companies like GF maybe be able to change their model because they have the manufacturing ready. That's what the big investments are if design becomes a lot more democratized. But I think that's things that are a decade out there. But that's it always comes down to what caused the separation in the first place and what would drive the integration. It's about a problem and a set of circumstances changed. Did those go away? Did the boundary conditions change? And now there's a new paradigm.
Yes. You know, here at Purdue, I'm always amazed every morning when I read my colleagues' latest work, ranging from the creative side to the discovery of drugs to the business side. And then when it comes to this particular technology area, I've always been amazed by the speed and the scale, the speed of changing the landscape with feature size shrinking ever so fast, and they have ever more of the transistors on a single chip, but also the scale at which you have these manufacturing facilities, these fabs, fabrication facilities. And you've got a few in GlobalFoundries, including a big one in upstate New York there near your headquarters now. One more commercial about Purdue. So yes, in the Bell Labs in the late 40s, transistor was invented, but the commercially viable version of transistor was invented in 1959, also at Bell Labs, by two researchers. And one of them is a boilermaker, John Atala, who had his multiple degrees from Purdue in mechanical engineering at that time in the 50s. And then, so he started out working at Bell Labs, and he's the co-inventor of MOSFET. And I learned that there's been more than 10 to the power 23 or 24, I forgot which one, so fact check me please, of MOSFET transistors manufactured since 1959. 10 to the power 23 or 24, that's a pretty big number. Might be the largest quantity of human-designed engineering artifacts ever produced. And we're not done yet, because there are so many per chip these days. Now, what do you think about
If it's not 24, it'll be by tomorrow.
You'll be by tomorrow, yes. That's the way it's going, right? And so what do you think about this industry? Is it sort of cutthroat? Is it, you're predicting a cyclic pattern exactly almost out of phase, right? When the market is hot, you have to anticipate the downhill. When it's cool, you have to say, this is the time to start planning, because building a fab takes a long time, a lot of capital expenditure, and then you have predicting the cyclic pattern into the future. You make a couple of mistakes, and then, well, you'll be losing a lot of money.
You captured the problem. It's an industry that moves fast, but the time constant to put capacity to address that moving need is much longer. And so it takes a lot of courage. It takes a lot of big bets. You got to be willing to fail once in a while. I'll give you a great example. In 2021, so many of our customers were calling saying, you got to get me more supply. None of this was ever forecasted. No one knew we'd get a COVID and we'd have a big refresh cycle of every electronic device, right? Changed the way we worked, played, and lived our lives. So in partnership with customers, not us making our own bet, customers actually using their balance sheet, their cash. We put a lot of capacity in place, and everybody kind of overdid it. They built a lot of inventory, and we're still, 2 years after this, as an industry at large, we have more capacity than demand, and it just, while we're all successful and have a high degree of sustainability, we've all built ahead of the demand. I'd say with the exception of, say, an NVIDIA and a TSMC for the leading edge because of the AI boom, the rest of us are still dealing with an inventory burn. So you say, is the industry cutthroat? I think the industry is so complex and so capital intensive and moves at such a fast speed. It's an industry that you almost have to be an adrenaline junkie to like being in it because it moves really quick. You're only as good as your last day. Tomorrow's the new challenge. We call it the semiconductor industry. Its other name is the problem-solving industry. Every day there's new problems, these new complexities we have to deal with.
Mm-hmm. Well, sounds like you have a stressful job, so maybe I'll come back to ask about stress. But what I want to ask you is about this bipartisan science, Chips and Science Act. Part of the goal is to strengthen Americans' national economic job security and revitalize particularly manufacturing in this industry. There's a reason why our country lost a lot of the manufacturing and the packaging capacities over the past 3-4 decades. And to reshore, onshore those capacities, the bipartisan Chips and Science Act was passed and was co-sponsored by Indiana Senator Todd Young.
Yes.
And Purdue has been indeed participating in that execution, including hosting leadership conferences and summits in Washington, D.C., including winning multiple most competitive research side of the CHIPS Act awards, a Digital Twin Award recently where Purdue is the lead academic institute in that consortium led by SRC, but also the education front, the industry front. What is your assessment of the CHIPS and Science Act execution so far?
Yeah, I'm gonna take a couple minutes to give a broader brush on all this. So, why did the nation need this? The nation needed this because I want you to hear about the semiconductor industry. Think about it as an inverted triangle. You have a $90 trillion world economy. I'd argue the center of that is the electronics industry, which is about $3 trillion, supported by a $600 to $700 billion semiconductor industry, comes down to a $100 billion foundry industry manufacturing. Household names, the NVIDIAs, the Qualcomms, the AMDs of the world, Broadcom, they don't manufacture semiconductors, they're the design part. And then there's foundries. There's 5 foundries in the world of any scale. And I'll make it an easy bar. $2 billion of revenue. GF is a $7-8 billion company. It's TSMC, UMC in Taiwan. Samsung, a division of Samsung, besides memory, they do foundry manufacturing. SMIC in China and GlobalFoundries. 5 for all of this. Now here's some of the dynamics. If you take TSMC's revenue, you take the revenue of the 4 of us, GF, UMC, SMIC, and Samsung, multiply it by 2, you get TSMC. That's how big they are. So industrial logic of concentration of capability. You take UMC and TSMC, and 70 to 80% of the world's production is in a very tight location. In industry, we always think about single points of failure. There are geopolitical risks, there are geological risks, and yet we wake up as an industry finding out we've taken one of the most important resources of the digital age called semiconductor, and we find ourselves in this highly concentrated situation. Can you imagine, you talked about the invention of the semiconductor in the late 40s and commercialization in the 50s. Those 4 fathers or those 4 women who were thinking about this industry didn't say, 60 years from now, success looks like 80% of the semiconductors are manufactured in Taiwan, then we've been a successful industry. It just happened over time, mostly because a country like Taiwan thought this was a strategic initiative and made co-investments with industry and created that. So what does the US say? They wake up one day and say, you know what? This is too important for national security, supply chain, economic security. We need to make sure we reshore semiconductor manufacturing. That's what the CHIPS bill is about. I think it's very successful. One, the CHIPS bill in itself is part of a bigger package. The key to it is to make the economics of building factories in the US comparable to other places in the world. We have higher levels of restrictions and regulations on the things we manufacture than the rest of the world, so it's leveling the playing field. You get 15% of your investment back from the CHIPS bill. The investment tax credit that goes along with that is another 25%, and states typically contribute somewhere around 5%. So you're looking 40 to 45% of a rebate back for every dollar you invest. That's why it's going to be successful. Now, some will argue it's taken too long. It was actually President Trump's first administration that started the wheels in motion, and it finally got passed into legislation as the CHIPS bill. It had many different names, including the Frontier Act, in the summer of 2022. And here we are at the end of 24, the money's actually starting to get deployed. When you make decisions and you're deploying $54 billion of taxpayer money, you better have a very rigorous process, vetting the applications, and know you're going to get the return on this. So I think it's a very successful program, but this is like everything else. You won't know now. You'll know 5 years from now, looking back, did the investments give the type of reshoring of manufacturing capacity, which the intention was for.
And
Those
GlobalFoundries is receiving some of those support for your upstate New York fab.
And for a Vermont fab, $1.5 billion. One of it is to create wide band gap capability in our Burlington facility, which is 200 millimeter. By the way, I'll advertise for a moment. Largest private employer in the state of Vermont, GlobalFoundries. And then in our upstate New York facility, 300 millimeter, we call it Fab 8, to do 2 phases of expansion there. One, we call it 8.auto, to make the diversification of our technologies broader there, which is what the auto industry needs, a broad range of technologies. And when the demand comes back in our industry, reinvestment in more capacity.
Oh, by the way, just so that in case you're wondering, what are these dimensions here? Well, are we talking about nanometers or millimeters? Well, I believe, if I'm not mistaken, I've been taught very well by my colleagues from the domain that the nanometer is referring to the feature size of the transistors, whereas the millimeter is referring to the size of the wafer. Because I got that question from one of my colleagues the other day, say, wait a minute, I thought, the smaller the better. I said that's the feature size, different from the size of the piece of pie of the wafer. Now, you mentioned your fab in multiple locations, and this particular fab in upstate New York. I haven't been in there myself, that particular fab. I've been.
Some of your students have been.
Yeah, I know, and you're going to hire people, right? So my question now is about workforce development. You can do all the wonderful research and innovation, deployment, translation. At the end of the day, as you said, whether it's design part or for your company, the manufacturing part, you're going to need a workforce that's ready to take on the challenge. And because of the lack of manufacturing capacity over the past 40 years in our own country, there are not that many jobs, and therefore not that many degree programs and training opportunities. But now that is changing. And I remember very well, Tom, that almost 3 years ago now when I called you up and say, hey, Purdue is going to launch this interdisciplinary SDP Semiconductor Degrees program with great faculty, and we're going to do that together with industry. And you endorsed us, you sent one of your technology leaders to join our industry advisory board as well to co-design, co-teach, and I have to say thank you also for GlobalFoundries' support for a lot of scholarships to support students like you were when you were a student who just would like to explore this, even though they may not have the means by themselves to go do certain industry internship or take certain extra credit courses. So thank you for the support on our scholarship program too. Now, on that workforce, I've heard very large numbers that we need to produce together between academia and industry. So what is your view on that workforce development, and how can universities and industry work together?
Look, the mega trend is we need more and more people educated with some degree of technical capability. The world's becoming too technology driven that even your most liberal arts of liberal arts, you still want some level of capability, statistics, because somewhere in your career, your life, you'll need that technical capability. I'm a big believer of just making the pie bigger of technologists, and then it's up to the industries to go make the compelling case for why we want to be a semiconductor professional versus any other kind of professional, and even within semiconductor manufacturing. And so how we make the pie bigger is create excitement around our industry. And I'm talking pie for semiconductor. We as an industry have failed in one very important element that you're very good at, marketing. We
I
never
thought you were going to say basketball.
As an industry, we never marketed ourselves. We were just maybe just too technology. Everybody knows what a semiconductor was. Nobody knew what a semiconductor was until there wasn't enough of them. When you couldn't get a washing machine, you couldn't buy a car, that a $50,000 automobile was sitting on a lot waiting for a $5 chip. Maybe the chip should have been $10, but that's a different story. Because that's another thing the industry did. It gave away too much value. It got caught up in its own, we double every year the productivity of our technology. That doesn't mean you have to give it away. You could have kept some of that for yourself. But the point was, once we started to create awareness, people started to wanted to see what was so fascinating about this industry, and you start to create momentum. And I think that's the biggest challenge for our industry, is to get people excited. And that means creating programs where when you're in college, they have plenty of choices of industries they can go to, independent of their discipline. Again, one of the things about semiconductor, almost any discipline, you can find great opportunities and roles in companies, from chemistry to chemical engineering, to solid mechanics to mechanical engineering. You name any technical discipline, material science, physics, every one of them has a place in our industry. And by the way, at most companies, you can have a career doing all of that without even having to change a company. So let me talk a little bit about workforce development. I want to show one chart of what we do, because it's a lot about end-to-end, the kinds of capabilities. So first of all, the one thing about semiconductor manufacturing, everybody in the economy or everybody in the country can participate at some level in our industry. You look at what we call our apprenticeship program. Apprenticeships are people with high school degrees, some of them come out of the military. How do we give them enough training to be able to come to our company and become technicians, vital part of how we run our factories, and then, by the way, support their continued growth in education. We announced something, the second bullet on this chart, a little over a year ago, where we said tuitions are getting out of control. Many students leave with a lot of debt. We're going to do a debt relief program. Actually, it's the third bullet down. The first $28,500 of debt that students come out with, we'll pay that for them. By the way, we do it in a very tax-effective way, so it's not like you're only getting half of it because it's taxed. We found a way to do it in a very tax-effective way. Some of those apprenticeships, back to 171 employees, use our continuing education to continue to skill up. By the way, it used to be $5,200 because that was the amount we could give that was not taxable. We've raised it to $10,000. We're trying to get the government to change the level at which it can be tax-free. So there's a fraction of that gets taxed, but still. We do annually over 400 in our worldwide footprint. By the way, I didn't mention we have a huge facility in Singapore and a pretty big facility in Dresden, Germany. And sometimes, by the way, when we have issues with green cards, that we allow employees to go work in one of our Singapore or Dresden factories, and then can reset the clock on their application for opportunity to live and work in the United States. But 400 a year of internships. By the way, that 400 is not limited by dollar budgets. It's limited by our ability to create an experience for students where they get enough mentorship and interaction so they can actually have a good experience, and we can actually get good productivity from those students. And then, as you see, with Micron recently, we invested $1 million in Micron NSF expand semis in the MSI. So you could see we have 16 strategic university partnerships. I view this one as one of the most important. We have 130 plus projects going on. Over 590 students are trained on our PDKs. That means they have access to our design kits and our IP that they can use to create their own product designs. 970 over the last, this is I think 3 years or 4 years, 970 student publications. By the way, if you want the best chance of winning an award at a premier conference on your paper, your best chance is doing something with GF, because you get to design and get to run silicon. So you do more than just design and simulate your design. You actually get to design, simulate, and actually characterize it. And we have GF 5 led courses on helping train people in this industry. So this is, we do a fair amount of what we call creating our pipeline of talent for our company. And it starts at the university level. It starts with recruiting, even out of high school. And what we look for mostly is give us people that are passionate about what they do, well-trained in their discipline, whatever engineering discipline it is, and we'll do the rest.
Well, this is an amazing chart, Tom, and I just want to quickly echo some of this, these numbers here on this chart. If I look at the first one there, the apprenticeship program is so important, and Purdue is working with, for example, Ivy Tech, which is the statewide community college here in the state of Indiana. We share a lot of our curriculum, our facilities, and work very closely with them on the apprenticeship program and associate degrees, because we need technicians. Yep. We need a lot of talents throughout the entire supply chain. The second bullet there, Purdue University Online happens to have a lot of online available master or certificate courses. We'd love to provide perhaps a small discount to your company if you become an enterprise level customer of our Purdue Online courses, and maybe it'll be under the 10,000 ceiling there. But
let me just comment on that for a second.
Yes.
We found that students can go take 3 years to get their master's from BS, and with this tuition reimbursement, it costs them less than $7,000 over the course of 3 years to go get a master's degree.
Yes.
The combination of these online courses, this reimbursement, spreading it over 3 years.
Yes, fantastic. And since you, I think, guest speaker in one of these courses, they're going to see you while they take those online courses. Now, affordability is a big topic to so many American families, and Purdue is very proud to say that since Mitch Daniels' decade, we have been freezing undergraduate tuition now for 13 years in a row. I know that that means a lot to some families, to many families, perhaps to your family decades ago when you were a teenager as well, and it means so much to many families today. So we applaud and salute your program to enhance affordability. And internship. Purdue has one of the nation's oldest and now largest, most prominent co-op programs, and we're very proud of having students doing learning while working. So, of course, perhaps Purdue is the most important global strategic university partner for GlobalFoundries. So I'm just turning your commercial slide into a Purdue commercial here.
Yeah. But let me point out two more. This apprenticeship program. Your certificate program is outstanding, and what we need to do as an industry with universities is make it more formal. Make sure that it really qualifies as something that everybody agrees, so that it's not one company thinks of a certificate this way versus another. An undergraduate degree, we all recognize it for what it is, and we need to drive that. So the certificate program has more value, and then the thing that I heard about today, what you're doing that's amazing, is this. It's a scale program where you do you start to get students ready for internships at the end of their freshman year, end of their sophomore year, where you invest. It looks like about $1 million a year. We sponsor some of those scale students, but it's a great. I got to see today 4 presentations on what people have done either in your vertical, your VIP program, or through scale. absolutely makes the internship that much better for GF and the student once they come in, having done that piece of work here.
And indeed, and it's not just for one particular technology.
Stars, not scale.
Stars, yes.
Stars.
And it's not just for one particular technology or industry, really. It's trying to revamp the notion of education in general as well. By the way, I cannot see every single face here clearly, but I think we have leaders of the SCALE program. Peter over there, STARS program, VIP program here, which is a broadly construed program for many different sectors. And you are right, standardization, interoperability, and appreciation of the values of certain certificates so that people do not need to explain what that means. That's going to be useful for the workforce development in the country, and Purdue, again, leading that. Now, before I turn the mic to students to ask you questions, I want to ask one more question specific about your company.
Okay.
Maybe two, starting with history, maybe tell us a bit more about how GlobalFoundries became an independent company. And two is, we talked about this physical aspect, right? And here in the Midwest, in Silicon Heartland, we tend to think of ourselves as combining the powers of the bytes and atoms, the virtual and the physical. So this notion of manufacturing, advanced manufacturing these days perhaps in different industry sectors, is core to a lot of what we do in research and education. And so the question for you is, people tend to just pay a lot of attention on what they call the leading or bleeding edge. The feature size is so small, we're talking about 2 nanometers. But that's not the only place where innovation and manufacturing happens. In GlobalFoundries, one of your fabs, for example, is not at that feature size, but nonetheless is employing a lot of advanced R&D results.
Yes.
So the second question, therefore, is what is the exciting next step in your R&D roadmap?
Yeah. So look, there's a lot to unpack there. So let's start with the GlobalFoundries story. GlobalFoundries story is the story of the industry where I started. It's about technology and economics intersecting. We talked about how over time the industry went from what we call vertically integrated companies, product manufacturing, that's how you went to market, to where scale mattered and not every company had the scale to continue to do that. We were born out of AMD. AMD got to a point where they didn't have enough scale to afford to build factories and do technology development and manufacturing and be a product company. So they had to choose what the best version of themselves was going to be, and they decided to become a product company, and they spun out manufacturing to create GlobalFoundries. Now, when GlobalFoundries was born, it was the only customer it had was AMD, and it didn't have scale, right? So by spinning it out, it didn't scale, and we spent the better part of the first 10 years building scale. Some of it in organic investment, some of it inorganic. We acquired the assets from IBM to build up this company to get to enough top-line revenue to have the scale to make investments. Now, in 2018, when I became the CEO, while we created scale, we were economically not sustainable. We were trying to play in the single-digit nanometer space where the types of investments, a $6 billion revenue company at the time couldn't make. You couldn't spend $3 billion a year in R&D and $10 billion a year on capacity when you only have $6 billion of revenue coming in. And so we looked at the market and said, well, while single-digit nanometer is interesting, it only represents 30 to 40% of the market opportunity. And the reason for that is back to the economics. Single-digit nanometer transistor costs more than the kind of technology that we innovated on. And no one was going to go spend more for a transistor if they could do the application better, in some cases, in the technology we play on. So we said, we're going to freeze, we're going to go to 12 nanometer, but we're going to build out and scale the features that matter. Anybody have one of these devices? I think people have them still use them, right? Smartphone? Do you connect your phone to cell tower? I don't care which one you have, you don't do that without GF silicon in it. We are the leader in the front-end module, which has all those connectivity to switches, the low noise amplifiers, power amplifiers, all that content is, no matter who makes it or whose phone is in, they do it through our technology. If you like secure pay transaction, we make the chip that does that. Remember, we don't design it, we make it for our customers. If you like the haptics chip that works the screen, we make that. All the power management chips that make the device battery life long, that's the technology our customers use that we create for their products. We have more silicon by square area in a smartphone than the application processor, the brain, that is on single-digit nanometer. And it's just the point of trying to simplify an industry to think that technology is one dimension. It's the size of your transistor. It doesn't do the industry justice, especially when more wafers, by almost a factor of 2, are sold in 12 nanometer and above technology in any given year than in single-digit nanometer because of the economics. So what does GF do? We continually innovate on the applications that require connectivity, embedded memory, digital processing with a lot of analog needs. The next generation radar for automobiles, I'd say 3 out of 4 suppliers of that, we're going to be on one of our premier technology platforms called 22FDX. If you are looking for embedded memory, look no further than our resistive RAM, our MRAM, and our ESF3 technology for depending what application you're looking for. These are the types of investments in our roadmaps we make. And what differentiates us, we're just not a kind of plain vanilla. Our strategic thrust is to innovate in what we call feature-rich, essential types of technology that create all these other features that, by the way, create the data that the world needs to do AI. Right?
Yes. Well, so you're saying that this wonderful Moore's law curve, you don't have to be at the tip of the curve to create values.
It's not the only way to create value. There's other dimensions of innovation. We spend over $600 million a year in R&D to make sure that we are anticipating market needs
Yes.
and customer needs to make sure that we have the technology for them. We think about the markets we play in as smart mobile devices, automotive, communications and infrastructure, and data center. And we think of these end markets, what are the technologies we can provide? Even in a data center where the vast majority of the spend is in GPUs and processors where we don't play, power delivery, in the future silicon photonics, those are technologies that we have huge leadership on.
Yes, and that R&D frontier for the kind of values that GF has been creating. I know that Purdue has a lot of great faculty and students, research staff working on topics ranging from new materials and new device physics to new hardware, software tools, to the type of manufacturing processes, including digital twinning for better yield and everything. So very exciting time for that collaboration too. Now, turning the mic to our students. We have a few students who want to ask questions, please.
Sorry. Hi. First to introduce myself, I'm Yash Singh. I'm a third-year computer engineering major here at Purdue. And I've been involved in the semiconductor here through the STARS program, the first one, and the VIP socket team. And before I ask my question, I'd like to thank President Chiang and you, Dr. Caulfield, for giving us the opportunity to learn from you and your experiences. And my question is, as global technological demands evolve, which industry sector do you anticipate will pose the greatest challenge for GlobalFoundries to adapt and remain competitive?
First of all, it's a great question.
Okay.
The biggest challenge I think we have as an industry, other than the area that's like on fire right now, which is data center AI, is what's the next big thing that's going to drive kind of a replenishment for all our electronics? 5 years ago, 6 years ago, every version of, say, a smartphone came with some feature that, hey, we have to have. Now they put a camera on the front side of the phone, got to have it. People are holding on to their devices longer. I mean, even the displays, the Samsung displays I have in my house, they're a number of years old because there doesn't feel like there's a reason to, there isn't a feature that I see that I would want to go invest and get something else. Now, the thing that we believe that's going to drive this next replacement cycle, so that's the risk. When are people going to start buying new devices? Is the promise of AI. That now people are going to want to buy devices that are AI enabled, and it's going to drive a refresh cycle. See, the investments that are being made in data centers right now will run their course. The economics will drive the fact that you can't do model training and inference in the cloud. It's just too expensive to have every question go to the cloud and come back. That the inference needs to be done at the edge. We call it AI at the edge. So every device will need that capability. Even if it doesn't use the chip that does the processing at the edge, it'll still need all the other chips we make that drive the connectivity, the security, and things of that nature. So the big bet for our industry is that AI is not just about what's going to take place in the cloud. That's going to become pretty much data limited very soon. It's going to drive a whole new class of products at refresh, where we need to do AI. The most important version of it is at the edge. It's in our hands. It's around the rooms and the places we live and go to school. So the challenge is, or the risk is, that doesn't happen. But it's hard to imagine for me that at some point we're going to need a refresh to take advantage of all the wonderful things that AI will be able to do for us.
Thank you. Next question, please.
Hello. First of all, thank you very much for this opportunity. My name is Isla Coach. I'm a materials science engineering student, and I'm a sophomore. And I have also been part of STARS program this summer.
I don't remember being so polite when I was your age. Thank you.
People often think of semiconductor careers as mainly for electrical engineers and computer scientists, but as you already mentioned, we know that the industry has a broad need for STEM talent, chemical, industrial, mechanical engineers, and material scientists, such as myself. What would you say to someone like myself, a student starting college or already in college, today about career opportunities in semiconductors?
Well, I think the career opportunities are there. You made a couple of really good points in the question. It's a range of disciplines, given the complexity of our business. It's not just a chemical engineer, it's a chemist, right? It's a physicist, it's a material scientist. That's what my degree is. I'm a material scientist, right? And I grew up in the engineering ranks. I think that how do you have a successful career in semiconductors is, I'd say, three things. These always seem to come in three. First, whatever discipline you choose, be really good at it. That's what you bring to the table. That's your subject matter expertise. The second thing is, to the extent possible, given the breadth of the complexity and all the things that the technological insight you need, do as much interdisciplinary learning as you can. So, you're you're a material scientist, maybe take a course to understand a little bit more on design in electrical engineering. So whatever you can in your electives that doesn't take away from your core of who you are, use those wisely to create that more interdisciplinary education. Remember, I'm using education, not vocation there. And then the last thing I would tell you, your biggest attribute, certainly compared to when I went to school, is you've been trained a lot better than any of us were in my day. I sound like such a boomer, on critical thinking and structured problem solving. Why? In my day, a lot of education was learning where to go find information. Today, information's right here, so you spend a lot more time learning how to be insightful and leverage that data. And the biggest challenge, I think, for students is they come out of a university setting where it's a lot of individual accomplishment. I mean, the team doesn't get a GPA, you get a GPA. And making that transition in complex businesses, it's the teamwork and your ability to collaborate, to bring your whole self, your ability to contribute your expertise to solving complex problems that are not easily solved as one individual in one discipline. And so this is the idea of be the best you can, because your teammates are going to count on your skill set for that problem that's a complex problem. Learn as much as you can about other disciplines so you understand that point of view. And third is really be good at problem solving and being structured in how to do that.
And then we indeed here at Purdue try to provide the education, not just vocation, and be able to uncover, not just to cover material. And let's see if there's another very polite question.
What a coincidence, they all sat next to one.
Good evening, and thank you, President Chiang and Dr. Caulfield, for being here with us today. My name is Neha Saleha. I am double majoring in electrical engineering and law and society. I was in STARS and VIP of Semiconductors, and fun fact, I actually interned at Global this past summer.
I think I recognize you.
Yes.
What was it like? Tell us the reality. What was it like?
Everyone there is really hardworking, and I really love my mentors. I still keep in touch with them, so that environment was amazing. So thank you.
Great answer.
So my question for you is, given GlobalFoundries recently announced their partnership with Quantum Motion, how do you anticipate the challenges of modifying GF's semiconductor fabs to accommodate the sensitive needs of quantum hardware computing in terms of budget and capabilities? Will quantum fabs be separated from classical fabs or hybridized into one?
Look, the volumes of quantum compute chips are not enough to create a factory for anybody. Now, the nature of quantum, you may need certain features or material sets that are different than the traditional CMOS ones, and we've found ways to go do that always. The meta point for me on quantum is I'm a big believer that matter-based quantum will never be able to be scaled to the billions of qubits you need to actually make it useful. And that's because of how electrons interact with one another. I'm a big believer that it's going to be photonics that will bring quantum to the forefront. And not only do we believe in it, we've invested in probably the most advanced company in quantum today, and they're leveraging our technology in silicon photonics, and the name of the company is PsiQuantum. What's very interesting, exactly to your point, some of the things that PsiQuantum needed to do in photonics required unique materials and capability that we incorporated into our fab in a way where we didn't contaminate our CMOS process, but enhanced our capability in photonics. So wrapping that all up, I don't think there'll ever be unique fabs for the quantum play. I think there's enough capability in existing fabs. They will need some new featurization and materials, maybe some processes. But the bigger point, I think, is when you see quantum in our lifetime, it's going to be photonic-based, not matter-based.
Wow.
You heard it here first.
That's music to, I know that's music to the ears of some of my colleagues here who work on quantum photonics. Do we have one more question? Yeah, please.
So first off, I'd like to thank Dr. Caulfield and President Chiang for this wonderful opportunity to ask this question.
Anybody else want to thank us while we're at it?
Okay, my name is Abhiraj Jaswal. I'm a first-year engineering student at Purdue, and hoping to get into computer engineering and especially semiconductors. So given the enormous financial and logistical undertakings that is involved in setting up a semiconductor manufacturing facility, what are some key roles or areas of expertise in your experience that would be better for a long-term viability and success for such operations? And how can we Purdue students better prepare for some of the more managerial or leadership positions in such an environment?
Yeah, look, the first one we talked about a little bit about the 3 points: be the best disciplined you can be, or best at the discipline, get as much interdisciplinary training as possible, and structured problem solving, critical thinking. I'd add one other point to that is your learning doesn't stop when you leave college. You have to be willing to be a lifelong learner. I graduated as an undergraduate in 1982. I'd be a Luddite if I stopped learning then compared to what I'd have to now. So worrying too much, am I getting enough training now, and is it the right training, is probably not the biggest issue. The biggest issue is how do you continue to learn, stay relevant. Technology is moving faster than most of society can keep up. So being disciplined and always having hunger and thirst to learn and being curious is the best way to hedge against becoming obsolete and not having the right skills.
Well, I'm going to abuse my power, not that I have any, and ask the last question. I usually do this at every end of every presidential lecture. The most stressful moment in your professional life. Now, I'll tell you one of mine, and you mentioned edge compute. So back in 2008-ish, 2008, 2009. At the prior university I worked at, started the Edge Lab, and then one day a leader in the field told me that, Mung, what are you doing? Everybody's going to the cloud. Nothing will happen on the edge. So that got me very nervous. I couldn't sleep very well that night. Did I just commit professional suicide here? Turns out that, you don't have to be correct. If you just, like a, broken clock face, you stay at the same spot, you're going to be right twice a day. So now the pendulum swings back and forth. But I was a bit nervous that night when I heard that. I don't know whether it was the night before your IPO or whichever date, early in your career. What was the most stressful moment in your professional life?
Okay, the most stressful moment also ties with the thing I learned the most about how to build your career. For me, it's you have to be willing to destabilize yourself. The minute you're very comfortable in what you're doing, it means you're stopping to learn. You're not doing new things. You're not bringing new tools into your toolkit or experiences that you can apply to problems of the future. And so this is in the late 90s. I'd been in management and in packaging at IBM. And IBM said, look, if you really want to grow and become a bigger executive in this company, you're going to have to get into the semiconductor side. And so I said, sure, I'm in. And I went over, and I was kind of a nobody with no credentials. And it was painful. I really disrupted my career. And there were times there where I asked the same question. Did I just kill my career? And I got a call back from the organization, and the manager I worked for said, hey, I hear you struggling there. You can always come home if you want. And then I knew, no, I got to if I can't make this work, I'll never be anything that I need to be. And so the most stressful part was I did exactly the advice I give to people in their career. If you want to have a career, you have to be willing to destabilize yourself. If you're too comfortable in what you're doing, then you're not learning and you're not adding new skills. And that one was maybe a big leap that I made. I could have done a little less disruption. But it reminded me, when you got through that, if you believe in yourself and you do the right thing, if I never took that job, I wouldn't be sitting in this seat today. But there was a 3 to 4 month period where I can sleep like a baby anywhere, but those nights were tough to sleep because of that idea that I've invested so much in this career that I just shoot myself in the foot.
Well, strategic destabilization perhaps in the institution, even universities perhaps, is an option that they may consider too. What a great evening. I could carry on for hours and hours with this kind of conversation like many of you. I want to thank you, Tom, for your support of our SDP, our R&D collaboration between the two institutions, and I want to thank you for visiting with us. I know that once you depart, we're going to be warmer here back to upstate New York. In the meantime, a big round of applause for Dr. Tom Caulfield.
Thank you. Thanks. Whoops. Where'd
Good
this come
evening.
from?
Voilà.
Thank you.